Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Good day, students. My name is Abdullahi, mathematics teacher at Mikab Model College. This moment, I shall be taking you numerical processes. And the part of these numerical processes that I will be taking you is laws of indices. And part of these laws of indices that we'll be looking at, one of it is multiplication law. The next one is division law. And the other one is zero law. And the next one is reciprocal law. And the next is power law and root law. So out of these listed laws, we shall be looking at the first two, which is multiplication law and division law. And in this multiplication law, we shall be taking a bit look at the a raised to the power of x times a raised to the power of y equals a raised to the power of x plus y. The law is telling us that a raised to the power of, if a raised to the power of x is given to us times a raised to the power of y, the thing there is that we have the same base, which is a and the next a. And we are going to look at this connectivity here. The connectivity will determine what is going to happen to the power. And after choosing one of these a, we'll write it down here. Then the connectivity shows that we are going to add the powers together, which is x plus y. Because the connectivity is multiplication, that is why we have to add the power. That is exactly what the multiplication law is telling us. And we shall apply this multiplication law in the following example. And the first example we shall look at is simplifying the following. A, 10 raised to the power of 2 times 10 raised to the power of 3. B, 22n raised to the power of 7 times 22 and 2 raised to the power of 2n raised to the power of 3. The solution of this goes thus. The first one is 10 raised to the power of 2 times 10 raised to the power of 3. If you now go back to the multiplication law, where we have a raised to the power of x times a raised to the power of y equals a raised to the power of x plus y, you can look at, if you can look at this very well and compare it with this, our a is equivalent to this 10 and our x is equivalent to 2. The y is equivalent to 3. And one thing that you must look at here is that the law will always be true if this a, x and y is not equals 0. You should recall that this and this must not be equal 0 before this law can be held. Therefore, this 10 raised to the power of 2 times 10 raised to the power of 3 will now be equals 10 raised to the power of 2 plus 3. And if you add these two together, we are going to arrive at 10 raised to the power of 5. This is the solution of this first example given to us. And if you must solve this kind of question, the index, which is 2 and is 3, we are going to take note of them. If this one and this are there, you look at this connectivity and the base. Then the 10 here is the base. You pick one out of the two according to the multiplication law. Then you add the powers, which are 2 and 3. So that is how we arrive at this 10 raised to the power of 3. I believe you clear with this explanation. So we shall look at the next solution of the second question, where we have 22n raised to the power of 7 times 2n raised to the power of 3. If you are given this kind of question, this one is a bit different from the first one. These are given in alphanumeric values, so we have to separate the numbers from the alphabet. So we are going to do the separation by saying there is every need. You look at it, there is every need for us to separate the numbers from alphabet as follows. So 22n raised to the power of 7 times 2n raised to the power of 3 will be separated as 22 times n raised to the power of 7 times 2 times n raised to the power of 3. In this sense, we are going to rearrange this expression at the right hand side of this expression. So if we must rearrange this, we are going to move these two closer to this. That is where we'll be having 22 times 2 times this first n raised to the power of 7, which is this one, times n raised to the power of 3. Now, if you look at this one agrees with the multiplication law, and we are going to pick one out of these two bases. So we are going to pick one, and we look at the connectivity, which is 7 and 3. We are going to add them together in the next expression that we are going to have, and for that we are going to multiply these two, which is 22 multiplied by 2, which is going to give us 44 times n raised to the power of 7 plus 3 equals this 44. This plus this one is going to give us 10, which is still the same thing as n 44 n raised to the power of 10. This solution of the second question is a bit different from the first one. You should have that in mind. Now, if you are given this does not mean that you are going to see only n and this 7 or n and 3 in every question. So it may likely be m or p, but if this is m and this one is p, you are going to leave them like that, because you cannot match m with p. So we are going to match n with n. If it is n here and you have m here, you are not going to match the two together. So we are going to have this 22 multiplied by these two when you are doing the separations. Then in our next law, the second law that we shall look at, which is division law. In this division law, you will agree with me that the previous one is having the connectivity of multiplication here, but in the case of this division law, we are having division sign that connects the a raised to the power of x and this a raised to the power of y. Once this happened, you are going to pick one of the base, you write it down. The first power, you write it at the top of the a, then the connectivity is division. You subtract the second power from the first one, and you are going to arrive at a raised to the power of x minus y. This is what the division law is telling us, that whenever you have the same base being connected by division, the power, you are going to pick one out of the two bases and you subtract this second power from the first one. So we shall look at the next example, which is example 2. And in this example too, we are asked to simplify the following. The first one is m raised to the power of 8 divided by m raised to the power of 5. And if you must solve this question, the m here is similar to this. Like the way I explained the previous example, I said once this one is m and this one is m, it means that you can pick one out of the two. And the solution goes thus. We shall look at the solution of that first question, where we have m raised to the power of 8 divided by m raised to the power of 5. And if you compare that with the division law, where we have a raised to the power of x divided by a raised to the power of y equals a raised to the power of x minus y. Now, if you compare this to this, our m is equals the a, this 8. Our x is equivalent to this 8, and our y is equivalent to 5. So we shall now remove this a from here and substitute this m in place of this a. And if you do that, you are going to have m raised to the power of 8 divided by m raised to the power of 5 equals, you pick one out of the two, this is it, which is m raised to the power of 8, where we have this to be equals 8, and y equals 5. You have 8 minus 5, and 8 minus 5 will give us 3. The solution of this question is similar to the previous one. The only difference is that the connectivity there is this that differs this one from the first one. The division sign here makes this to be subtracted from this one, and the previous one you have to add the two powers. So we shall look at the solution of the second question under this division law, where we have 9 multiplied by 10 raised to the power of 9 all over 3 times 10 raised to the power of 3. This one equally represents our division sign. That is to show that this can be transformed into 9 times 10 raised to the power of 9 divided by, you put everything here into brackets by having your 3 times 10 raised to the power of 3 within these brackets. So in this case, if you look at this, the connectivity between this 9 and this 10 raised to the power of 3 is multiplication. The connectivity between these 3 and 10 raised to the power of 3 is multiplication. But the connectivity between this 9 and 3 is this division sign. The connectivity between this 10 raised to the power of 9 and 10 raised to the power of 3 is also the division sign. This can be transformed into 9 divided by 3 times, since the connectivity between this and this is multiplication. That is why you are having this multiplication sign here between these two and this 10 raised to the power of 9. So 9 divided by 3 multiplied by 10 raised to the power of 9 divided by 10 raised to the power of 3. So 9 divided by 3, we are going to have 3 in that case. The multiplication sign, you bring it here. The connectivity here is division. So we are going to subtract the first sign, you are going to subtract the second power from the first power. That's according to the division law. We are going to arrive at 9 minus 3 at the power of this 10. So by so doing, we are going to arrive at 3 times 10 raised to the power of 6. The solution of this one is different from the previous one, where we had m raised to the power of 8 divided by m raised to the power of 5. In that case, the m and m, they are straightforward. And in the case of this one, you have mixture of 3, 9, 3 and this 10 and 10. This one, it is only this one and this one that's similar. This one and this one, they are not similar. So you have to divide this one by this one in this case to arrive at this 3. In the case of this one, you are going to have 10 raised to the power of 9, then 10 raised to the power of 3. You choose one out of these two. You are going to arrive at 9 minus 3, which will give us 6 here. So in our next lesson, we shall look at the other laws of indices. Thank you for today.